Welcome to Math 201 lesson on section 3.4, the chain rule. Let's begin, as we have begun all of the sections of chapter 3, by listing the derivative rules and shortcuts that we know so far. So we are going to start with the power rule that says that the derivative of x to a number is nx to the n minus 1. And then we have an exponential derivative rule. We know the derivative of a to the x is a to the x times the ln of a. And we have a special case of that one, that the derivative of e to the x is e to the x times the ln of e, but the ln of e is 1. So it's just e to the x. Okay, and then we have the product rule that says the derivative of f times g is f prime g plus f g prime. And we have the quotient rule that says that d dx of f over g is f prime g minus f g prime all over g squared. And then we have a couple of properties that are sort of like the quote unquote obvious properties. The derivative of f plus or minus g is just f prime plus or minus g prime. And the derivative of a constant times f is just the constant times the derivative of f. So we're going to do a quick review of what it means to compose two functions. I have f of x equals e to the x and g of x equals k times x, and I want to compute f composed with g of x. So you remember that this little open dot means composed with versus multiply, which is the colored in dot. So this means f composed with g, which means f of g of x. It means we're taking g and putting it inside of the function f. So this g of x we call the inside function. Okay, and then f we often refer to as the outside function. So if I want to calculate f of g of x, g of x is the function k times x. So I'm just going to replace g of x with its formula. This is f of kx. Okay, so I'm plugging kx into the function f. So f of x is e to the x, so I'm going to replace the x with a kx, and this is now e to the kx. Now I want to look at a function m of x, which is the square root of x squared plus 7 to the x, and I want to decompose it, okay, into an inside function g and an outside function f. So I'm trying to rewrite this as f of x is a function and g of x is a function, so that f of g of x is the square root of x squared plus 7 to the x. So my inside function is going to be x squared plus 7 to the x. That's inside the square root. So we're going to call that g. And then my outside function is the square root, and we're just going to call that square root x. So that when I compose these two, when I take the formula for g and plug it into f, I'm going to get the composition, radical x squared plus 7 to the x. Finding the derivative of a composite function requires something called the chain rule. So the idea is that you're going to apply the normal derivative rule to the outside function and then multiply by the derivative of the inside stuff. So let's look at the example we just decomposed. Um, we said that the inside stuff was x squared plus 7 to the x. My inside function was x squared plus 7 to the x. So I could just think of this as the square root of some stuff. I find it helpful to label the inside function just stuff to wrap my brain around what I'm doing. Okay, and then the square root is the same thing as the 1/2 power. So I'm going to write it to the 1/2 power so that maybe I can use the power rule. So that's some stuff to the 1/2 power. So m prime says that we just apply the standard derivative rule. I'm going to bring the 1/2 down. I'm going to copy the stuff. I'm going to reduce the exponent by 1. But then I also have to multiply by the derivative of the stuff. Okay, that's what the chain rule says. Apply your standard derivative rule, but then also multiply by the derivative of the stuff. All right, I'm going to go back in and replace the word stuff with x squared plus 7 to the x. So this is 1/2 times x squared plus 7 to the x to the negative 1/2 times the derivative of x squared plus 7 to the x. And then I will take this derivative and then I'll be done. So this is 1/2 times x squared plus 7 to the x to the negative 1/2 times 2x plus 7 to the x times the ln of 7. Let's look at another example together. I want to take the derivative of e to the kx. We actually figured out what this is last class using the product rule, but we're going to do it today with the chain rule. Okay, so we are going to think of this as e to some stuff. Okay, so my derivative is going to be e to the stuff because the derivative of e to the x is e to the x. So the derivative of e to some stuff is e to some stuff, but then I also have to multiply by the derivative of the stuff. Okay, so this is e to the kx times the derivative of kx. So this is e to the kx. The derivative of kx is k. So this is k e to the kx, which is exactly what we got in the previous lesson when we did this with the product rule. So to formally write down the chain rule, it says that d dx, the derivative of a composition f of g of x, is just f prime of g of x. So you do the derivative of the outside function with the stuff, right? But then times g prime, that's times the derivative of the stuff. Okay, and then same, I've written the same thing out here, except instead of using g of x as my inside function, I wrote the word stuff. For some reason, I find that easier to think about. D dx of f of some stuff is just f prime of the stuff times the derivative of the stuff. Okay, we've come to an activity for lesson 3.4. Please pause the video at this point, work through these problems, and come back to the video when you're ready to see the solutions. Okay, welcome back. We are going to use the chain rule to take the derivative of each of the following functions, e to the 4x. So we're going to think of this as e to some stuff. So the derivative of e to some stuff would be e to the stuff because the derivative of e to the x is e to the x. So the derivative of e to some stuff is e to the stuff. But then I have one last step where I have to multiply by the derivative of the stuff. Okay, so instead of stuff now, I'm going to write 4x. The derivative of e to the 4x is going to be e to the 4x times the derivative of 4x, which is 4. So this is going to be 4e to the 4x. Okay, I want to take the derivative of the square root of 2x minus 9. So I am going to think of that as the square root of some stuff, or alternatively, some stuff to the 1/2 power. So if I want to take the derivative of that, some stuff to the 1/2. So the inside is what I labeled stuff. And now I'm going to apply the power rule to the stuff. So there's going to be 1/2, copy the stuff, reduce the exponent by 1, but then you also have to multiply by the derivative of the stuff. Okay, so that comes out to, actually, let's rewrite it with 2x minus 9 instead of stuff, d dx of 2x minus 9 to the 1/2 is going to be 1/2 times 2x minus 9 to the negative 1/2 times the derivative of the stuff. And the derivative of 2x minus 9 would be 2. Um, and typically, I give you the advice not to simplify your derivatives unless you have to. But if you can significantly simplify something in one step, I say do it. So I'm going to times 2 and times a half. Those cancel to 1. So this is just 2x minus 9 to the negative 1/2. Okay, I want to take the derivative of 7x plus 2 to the 19th. Think of that as some stuff to the 19th power. So if I want to take the derivative of some stuff to the 19th power, I'm going to apply the power rule to the stuff. So this is going to be 19 times the stuff, 7x plus 2, reduce the exponent by 1, and then times the derivative of the stuff. So that's 19 times 7x plus 2 to the 18 times 7. All right, I want the derivative of e to the h of x, where h of x is any differentiable function. So think of h of x as some stuff, right? In fact, it's more clearly just some stuff than if I had written something explicit there, like part A, where we did e to the 4x, right? So this is e to some stuff, which means the derivative is going to be e to the stuff, just the regular derivative rule. But then you have to multiply times the derivative of the stuff. The function e to the square root of x cubed minus x is too complicated to differentiate with a single application of the chain rule. So how do we find the derivative? We're going to have to do the chain rule twice. So let's start by writing it out. This is d dx of e to some stuff, right? And the stuff is another composition, but I'm just going to write it as stuff for right now. Okay. And the derivative of e to some stuff is e to the stuff times the derivative of the stuff. Okay, so let's replace the word stuff with square root of x cubed minus x. Okay, so this is going to be e to the square root of x cubed minus x times the derivative of the square root of x cubed minus x. I'm actually going to rewrite that as x cubed minus x to the 1/2, so that when I take that derivative, I can do the power rule. Okay, so I have e to the radical x cubed minus x. And now I still have to do the derivative of x cubed minus x to the 1/2. This is the derivative of the stuff. But this derivative involves the chain rule. This is another composition. I have some stuff to the 1/2 power. So I'm going to apply the power rule to the stuff, right? But then I'm going to multiply by the derivative of the stuff. So here I'm just copying the part of the problem that's done, e to the square root of x cubed minus x times, now I'm working on this derivative. Bring the 1/2 down, copy the stuff, reduce the exponent by 1, then multiply by the derivative of the stuff. Okay, and then one final line, most of which is copying, right? I'm going to copy this factor, and then I'm going to take this derivative. Okay, the derivative of x cubed minus x would be 3x squared minus 1.